game to construct a logic circuit of a washing machine control using a generalized simulator, and we are going to verify the output. Interaction: when the logic gates are connected together to produce a specific output for a certain combination of input variables. There's no storage involved, so this may be resulting the circuit is called as combinational circuits, and this combinational circuits maybe the basic aids can be used for the various applications such as washing machine control, level monitoring, and indicating on applications in manufacturing processes, and elevator control applications, a warming indication application, and in binary additions and for subtractions and for multiplication circuits. Okay, now we're going to see what are the applications of a washing machine controller. Okay, there is a three sensor which is based on a washing machine controlled, namely door sensor, water level sensor, and this temperature sensor that produces digital outputs. Okay, the controlling action include the control of water valve, heater, and the motor. All these are digitally controlled by a device. The concept is the motor of a washing machine turns on when the temperature and the right water level, and obviously when the door of the machine is closed. See, the system involves three input D, L, and T, representing door position, level, and temperature respectively. It controls three output W, H, M, representing water valve, heater, and motor respectively. Now we can discuss the logic behind them. See, when D is equal to 0, the door gets opened. When D is equal to 1, the door gets closed. When L is equal to 0, the water level is low. When L is equal to 1, the water level is high and it's satisfactory. When T is equal to 0, the temperature is low. When T is equal to 1, the high temperature and it is the right value. Now, the truth table for this application can be developed by logical reasoning. For turning on any output devices, the washing machine door should be closed at any point of time so that only last four cases of the truth table should be considered where D takes a value 1. If the door is closed and the water level is low, the water valve should be turned on. The door is closed when water level is satisfactory or high and the temperature is low, the heater should be turned on. Whereas the door is closed and the water level is satisfactory and the temperature is right, the motor should be turned on. This is the truth table for the washing machine. See, we have to consider only those inputs that produces the high output, and we get the reduced Boolean expression for controlling as follows. See, the water valve, heater, and the motor, which is given like this. And in this corresponding, there's a corresponding logic circuit diagram is shown below. You can see the logic diagram. See, this is the logic diagram. Based on this logic diagram, we're going to do the simulations. Okay, right? We will see the simulations. This is a procedure. In this, you have to turn or off the input D, L, and T according to the truth table, and you have to note the output for the various combinations of input, and you have to validate the design work as per the problem statement. See, the motor of the washing machine that turns on when the right temperature is correct and the right water level, and obviously when the doors of the machine is closed. And then we are using the simulator build the washing machine control circuit, and we are going to verify the result. Okay, see, this is the truth table of the combinational logic circuit where the door level and the temperatures are said to be the input and the valve, heater, and the motor are the output. We'll only consider the input conditions when they produce the high voltage. This is the logic diagram of combination logic circuit. Okay, now we are going to plot this. When you give the door level and temperature is kept on, the motor gets updated. When the doors and level are given as the input, you will get the heater as the output. When you give a door and the temperature as the input, you can get the water valve as the output.